Dr. Knaak.
Dr. Bilo.
Amsterdam.
Amsterdam.
PC Hoofdstraat. It's actually one of the most busiest shopping street and the most luxurious shopping streets in Amsterdam.
Well, not on a Wednesday morning at 9:30.
You're right.
Rain.
And it rains, yeah.
So we parked the car in the middle of the street, which is super cool. We're gonna see Erwin ten Brinke. He's a structural engineer at the company called ABT. And, he's a glass freak, and he was in a leading role for this super nice shop, which we're going to see, which is a solid glass structure.
It's the Crystal House.
Crystal House.
Yeah. Actually, colleagues of ours within the TU Delft engineered, and also at the very end, Phaedra, colleague of ours, a PhD researcher back then, built it.
They even built it. Yeah, Erwin's going to tell us everything about it.
Perfect. Oh, can't wait. Let's get out.
Rolling?
Yeah.
Okay. Erwin, thanks for being here. Rainy day. Sad. Well. Stop. Zweite. Hello, Erwin. Thanks for being here. Rainy day in Amsterdam. Naja. We're going to talk about a super interesting complex glass building. And the questions we're going to talk about: how to develop a complex facade, here as an engineer dealing with the designer, how to engineer such a complex facade, which technology didn't exist, and how to then build it, which is another interesting question. So let's start with how to develop a complex facade. The first idea, design to technology. How do you translate it to a design? How do you translate it to a technology? And the do's and don'ts of such a process.
Okay, well, the whole idea started with, of course, the architect. He had this idea of making a glass facade. And if you would look around in this whole neighborhood, you're allowed to adapt your store, but only on the first story. But only making a glass facade on ground floor level, well, that just doesn't look okay. So therefore, the architect, he went to the municipality and said, well, I will make this whole total glass facade of 2 stories, and I will promise you, I will make it as it was before, but then totally made out of glass. And that's why he was allowed to make a 2-story high glass facade in this street. That's where it started, and he made a promise. But how to materialize it? I mean, would it be glass? Would it be plastic? At that time, we didn't have a clue yet. So the architect came to us and said, well, I have this brilliant, nice idea of making a glass facade, but I don't know where to start, so please help. And that's where we collaborated, ABT, together with Unimas.
And then the do's and don'ts of such a process.
Well, never say no, and just always say, okay, yeah, I like this idea, and try to make something out of it. Not throw it away by your judgment, which you had informed me as well. It's never done before, so it's a bad idea. No. Embrace every idea there is, and well, try to think of something, and that's what we did also here. Just say yes and try to, well, get those brains work and find a solution for what may come.
You really like it, thanks. Now you're the engineer of something like this, so you have this total solid glass structure. Technology doesn't exist, system doesn't exist, the material, well, it exists, but glass bricks, I haven't seen them before.
What was very interesting is that also the client was very dedicated, and he was eventually the one who found the glass bricks in Murano. So, and then, well, it started to have a lift off. I mean, first we had the bricks, but then we didn't have glue. What glue? Should it be transparent? Should it be translucent? So in that way, we involved the University of Delft, who did all the testing, and by doing tests and finding the right material, in the end we could think of engineering something like a facade of glass bricks, well, which has never been done before.
What's the main complexity of stacking bricks? Because I don't see any mortar, just 3 bricks.
Yes, you're correct. It's the gluing. What you see are glass bricks, and they're glued. And they only have a tolerance of 0.25 millimeter. That's
Quarter millimeter.
quarter of a millimeter. That's nothing, you know. And what's interesting, if you look at those piers, which you can see here, gluing bricks to a wall, that's not a problem. But where they have to connect on top of the facade,
The arches.
that should still be 0.25 millimeter. So that was the most difficult part, to get that correct. And how we made it?
Exactly. That's the last question: how to build such a complex facade. So, who's going to manufacture it? And what about logistics? Getting all this, 7,000 bricks manufactured?
Yes, 7,000 bricks. And you can imagine, so it's the first time we found the material. It's the first time that we had the glue. So there weren't any producers who could glue this. So it was the TU Delft who invented a way of gluing these glass bricks. And they learned, two brothers called Poppe, the two brothers, they learned from them how to glue this glass facade. So there are only 4 people in the world who can glue glass bricks. And that's how it's made.
And then obviously the last question, this seems to be super complex, the client needs to be delegated, really needs to want this because he needs to pay for it, and it takes a lot of time. Did it work in the end? Are they happy?
Yes, we're standing here in front of a flagship store. I mean, so what it needs is publicity, and that's what it got. Since it was realized in 2016, they got a lot of publicity. So yes, the client is very happy with this great and stunning facade.
Thank you. So Erwin, it works. It's in a public space. I'm gonna bitch you now. I have my screwdriver.
Yeah.
What will happen if I start peeling into the mortar?
Nothing will happen. And if you have a big, like a hammer or something, and you would like to take one out, we have a system. We find out a system that we can replace bricks for new ones.
So I peel off one of these bricks.
Yes.
And then it's taken out, and then there's a new one brought in with this 0.25 millimeter tolerance in position. That's a tricky one. That's not to say simple replacement. How many people would be able to do so?
Like I told you before, there are 4 people in the world who can do so, and it's tested. I mean, I'm just making this up. I mean, this is a scenario which was tested. I mean, you have to test it because it's in the public area.
Thanks. And now we really look at it. Huh? So this is really, that's UV.
It's zelfs harder dan het glas.
And this is silicon.
Yeah.
This is the silicon part.
Yes.
And it's even shaped here.
So we started with gluing the bricks, and afterwards the glass frame was built with the silicone here. And there's even more glass, but because beside of the frames, you still have the subframes, which are made of glass, and the glass is of course made of glass. So what you see here is you have layer behind layer behind layer behind layer, and that, well, what I find the beauty of this total facade.
It's the real setup of a normal, typical Dutch traditional building. Brick, timber, glass, and it's all done in glass in one go.
And if you're once here in Amsterdam and you go to the front door, you see even that the doorknob is made of glass.
Oh, I have to check. That's the doorknob, actually out of glass. Kunnen jullie nog hier even wijzen?
What we also found out, and that's one of the interesting things, what was glued was the horizontal part, and the vertical one is still open. And what you can see is the mirroring effect. So if the clothes which are hanging here, they have really great light. It's very diffuse, and that's why it becomes even more beautiful with all those mirroring glass bricks than you would have only from normal light. On top you see the architrave, and it's built in a vertical way, because you can imagine that glue, it's just fluid, it's super liquid. So the TU Delft made a very intelligent system where all the glue would stay horizontal, and so they could glue bricks in a horizontal way. So in fact, it was made vertically and then transported to...
It was slowly tilting. It was slowly tilting by being assembled, and then it's brought in position.
Yes, that's how it's done. So there's a solution to everything, but just you have to engineer it.
Yeah, well, you have to engineer
That's it. Thanks. Was a good one.
You take that one.
See you at the car.
Nou, hier is een mooie glazen deurknop.
ik ja te zien. Er is wel een stalen raam om die deur.
Ja, dat wel, maar die heeft te maken met inbraak, weet je wel.